Beiter here with the notes on electricity. Words to know: electron, proton, electric field, static electricity, friction, conduction, induction, law of conservation of charge, static discharge, voltage, resistance, series circuit, parallel circuit. Key questions: how do electric charges interact? What are the two types of electricity? How are electric charges transferred? What is the relationship among electric current, voltage, and resistance? What is the difference between series and parallel circuits? How do electric charges interact? The charged particles in atoms are electrons and protons. Electrons have a negative charge and protons have a positive charge. The two types of electric charge interact in specific ways. Charges that are the same repel, charges that are different attract each other. The rule for electric charges is the same as the rule for the magnetic poles. However, magnetic poles cannot exist alone. You have to have a north and a south, but electric charges can exist alone. What are the two types of electricity? Well, objects that have equal numbers of protons and neutrons are neutral, and they have no overall electric charge. Protons are tightly held by the nucleus of an atom, but electrons can sometimes leave their atom, so they're mobile. And we have to know this difference to understand these two types of electricity. In insulators, like wood and rubber, the electrons are held on tightly, whereas in conductors, those electrons are allowed to move and to flow. A neutral object can become charged by gaining or losing electrons. And by understanding this, how electrons can move, we can understand these static electricity and current electricity. Static electricity is that buildup of electric charges in an object. And you have a static discharge or an electric shock when they suddenly jump from one surface to another. Current electricity, though, is the flow of electric charges. So flow of electrons through a conductor. So where static electricity is that jumping of electrons, current electricity is the flow of electrons. So we can see examples of static electricity here, and the flowing of electrons in a circuit, that is the current electricity. So how are these electric charges transferred? Well, in static electricity, those charges must be transferred from one object to another, and it's either by friction, where we have one object rubbing against another, or conduction. That is by direct contact, and a lot of times that is the conduction or the current going through it. Induction is the movement of electrons from charged object to another object through another object. And the static discharge is that electric shock that you can get when you rub your feet on a carpet and then touch your little brother or sister. When a negatively charged object and a positively charged object are brought together, the electric charges move until both objects have the same charge. They reach the electric equilibrium at the same number on each side. The law of conservation of charge states that charges cannot be created or destroyed, but only transferred from one location to another. So in current electricity, in electricity in general, we have some terminology, and that terminology includes the current, the voltage, and the resistance. Electric current is that flow of electric charges, and you'll have a potential difference or the voltage. And the greater the voltage, the more current that there is to flow. This is a potential difference in that, think of the more voltage it is, the higher something is up in the sky, the more gravitational potential energy it has, or the more electric potential energy it has. So it has more stored built-up energy able to flow.
This battery has a voltage of 1.5 volts. It's a D cell. Every battery has a voltage listed on it. That's the electric potential difference for that battery.
The resistance is the prevention of that flow of electric charges. So the greater the resistance, the less the current can flow.
I've hooked up two D-cell batteries together, each one 1.5 volts. If we add 1.5 to 1.5, we get 3 volts. And we look at our voltmeter, which measures voltage, we can see that it is very close to 3. And it's not quite 3 because of resistance. So we can determine the voltage based on what it says on the batteries, but we can also measure it using a voltmeter.
So let's look at a circuit. An electric circuit is a complete path through which electric charges can flow. If the path is broken, the electric charges can't flow continuously and the current stops. So we have to have that complete flow. A switch is often used to get that flow to either go or not. And we also have things that are used in the circuit, like lamps or fans or any other number of things that are used within that circuit. And we also have to have a source of electricity, which is often a battery in these diagrams. And if we look at this, we need to be able to tell what some of the basic symbols are for an electric circuit. Switch, a lamp, there are several different diagram symbols for lamps, and a battery. Two main types of circuits you need to know about: the series circuit, where we have things that go in one path. So in here we have 3 resistors, we have 2 light bulbs in one path. There's only one way for the electrons to go. In a parallel circuit, there are several paths, several ways that those electrons can travel. They have multiple paths or separate branches. That is a parallel circuit.